So now it is time to connect what you learned about thermodynamics, electrochemistry, and equilibrium and put it all together. Okay, so when you look at the sign of E cell, that can tell you whether the cell is thermodynamically favorable or not. So if E cell has a positive sign, okay, that indicates that it is thermodynamically favorable, which would indicate that it is a galvanic, okay, or voltaic cell. Okay, and if it is negative, it is thermodynamically unfavorable, and that would indicate that it is a electrolytic cell. Connecting to that to delta G, okay, you can use this equation, delta G equals negative NFE. I think the AP handout actually gives you the standard delta G equals negative N F and then E for the standard condition. Okay, now we have to make sure you understand how exactly the units work and what these stand for. So N is recorded in terms of the number of moles. Okay, and then F is what you call the Faraday constant. And the Faraday constant, you could estimate it to be, it's 96,485, but we're going to go ahead and use, just for purposes of this lecture, 96,500. And the units are coulomb per mole of electron. That can become important when we do some of the stoichiometry with electrolysis later on in the unit. And then E is measured in voltage, which we talked about earlier as being joules over coulomb. Now, when you use this equation, you're going to see that the moles cancel and the coulomb cancel. Therefore, the units of delta G will be in joules. And it's commonly recorded in kilojoules, but if the question just asks you for the value of delta G, you can use, and it doesn't specify a unit, you can either use joules or kilojoules, whichever one is more convenient for you. Okay, now this hopefully makes sense. You know that if E is negative, meaning thermodynamically unfavorable, and if this was negative, because you have a negative here, that would result in an overall positive value for delta G, which would indicate a thermodynamically unfavorable reaction. Okay, conversely, if E is positive, that means this whole value would be negative, and that would tell you that delta G is negative, meaning thermodynamically favorable. So hopefully that makes a good connection to thermodynamics and between thermodynamics and redox electrochemistry. So now I'm going to put all that together in this problem. So the first thing I'd like you to do is go ahead and look in your book and look up the reduction potentials for Cu2 plus to Cu and Fe2 plus to Fe. So pause the video and write those two reduction equations. So for the reaction, it's written, you would see based on these two reduction potentials, you can see that it was this reaction that was happening as a reduction, which means that the second one must be occurring as an oxidation. So I'm going to go ahead and rewrite and flip around that second equation to Fe solid to Fe2 plus aqueous plus 2E negative. And that now becomes an oxidation potential of positive 0.44 voltage. Okay, and cross off this line. And then you can see that the Cu2 plus and the Fe are on the reactant side, and the Cu and the Fe2 plus are now on the product side. Okay. So what we can do now is we can find the value of E cell. by adding the reduction in oxidation potential, which would be positive 0.77 voltage, also known as Joule Coulomb. Okay? And so one way we can tell that the reaction is thermodynamically favorable is that you have a positive value for Ecell. And I just noticed there's a little bit of a typo there. I should have 0.78. Okay, sorry about that. And so the positive value of Ecell indicates that the reaction is thermodynamically favorable. But let's also go ahead and calculate the value of delta G, okay, which is negative NFE. So in this case, it's negative, and 2 moles of electron were transferred in this process. So I'm going to put 2 moles of electron times the Faraday constant of 96,500 Coulomb per mole of electron, okay, times the Ecell, 0.78 volts, which comes out to Joule Coulomb. And the moles of electrons will cancel, and the Coulomb will cancel. And so when you enter that in your calculator, and you get the sig fig, okay, that should come out to approximately negative 1.5 times 10 to the 5th joule. Okay, and that negative value of delta G indicates, once again, that the reaction is thermodynamically favorable. Okay, and also make sure you're thinking about what they're telling you about the value of the K equilibrium constant, if this could be represented as an equilibrium. And that's something you'll be thinking about, maybe something you put on the discussion board, or something to look at when you're completing the pre-test. Okay, so that is it, talking about the Ecell and the delta G.